Okay, everyone, so let's talk control volumes. So right here, I have a spaceship going into space. And what you can see is that there's a whole lot of mass shooting out the back. And so how would you draw this control volume? Well, I can do it a whole bunch of different ways. I can, if I wanted to, trace this guy perfectly, and let's see, got this guy right here. There we go. This, yes, doing good. All the way around. Beautiful. There is my control volume. However, that's not actually necessary. You don't have to have the perfect shape. Plus, tracing like that is horrible. You can simplify things. Like, all that really matters right now is this rocket. So what I would probably do is simplify this quite a bit. I might even just draw the rocket, because that guy is the one that is important to me. Okay, let's bring this guy over here. Rocket shape. Now, if I'm thinking about this though, it's not a perfect rocket shape because I don't have fixed boundaries everywhere. That guy right there is fixed. The top is fixed. But I do have something coming out the bottom, so I should have drawn that as an imaginary boundary. So let's try one more time here. So there's my imaginary boundary. I can go up, go over, and down. So I have mass in here, and that mass is going to be changing with time. And how it changes with time is going to be important to us. Why? Because it's actually how you figure out thrust. I'm going to have mass going out. How we determine how much mass is in there later? Well, that's a question for a little bit later. So you can see I have an imaginary boundary right here. I have a fixed boundary right here. And that's it. Now, if you're wondering to yourself, well, why do I care about drawing this? And what if I do it wrong? It's not super important that you draw it perfectly. I could have very well just drawn this as a box. Like, that's completely fine. There's a bunch of different ways you can draw. There's not one particularly right way to do this. It's a tool you're using to help yourself solve the problem. So draw as much as you need to help yourself solve this problem. Let's try another one. Okay, so we got another open system. It's got one inlet and one exit. Where are those inlets and exits? Well, this is your hot water heater, so they're usually on the top. You got cold water going in, you got hot water going out. So how are we going to draw our control volume? Well, I'm just going to draw a rectangle, and I'm going to make sure that I have two inlets. I got to make sure there's imaginary boundaries. I did it again. There you go. Perfect. One has cold water going in. One has hot water going out. You can add little details like that if you want to. If I wanted to, I could write down the volume. I'm just going to say that it's 50 gallons. And I can even write down the temperatures in here, which is, let's say, 126 degrees Fahrenheit. Is that what it really is from my hot water heater? I have no idea. I haven't checked in a while. So add the details you feel you need to solve a problem. And if somebody adds more detail than you, don't worry about it. If they need that, good for them. If you don't need that, good for you. Add enough that you understand what's going on. And also, bigger than that, add enough that you know where you need to do your calculations. Like for me, this is where the mass is changing, these 2 points right here. If I understand what's going on at those 2 points, I can solve a lot of problems. Other things that might be important is, if I know what's going on at those 2 points, I can actually figure out how much heat is going into this hot water heater, because I can tell what is the difference in the temperature of the cold water and the hot water. If I know what the difference in temperature is, as well as their mass, I can actually figure out the heat. How do we do that? We'll get there eventually. Hold your horses. That's chapter 2. At least beginning in chapter 2. Okay, so we're going to stop here for control volumes. Thank you all for listening, and I'll see you all next time. Bye-bye.